Algebra 2, 8.3, we're going to talk about the number e today. And the number e, guys, is a naturally occurring number. And the way they find it, or they actually find all the digits of e, is use this little expression right here of 1 plus 1 over n to the n power. So what we're going to do real quick is just kind of make a small table. I would have to say you guys are going to get your calculator out. That if I put n in to our equation here, and I put our equation at the bottom, what happens when I put in, say, 10? What happens when I put in 100? What happens when I put in 1,000? What happens when I put in, say, 100,000? Okay? Let's take a look at the number that comes out. Let's just go to like 3 decimal places. I'll pause the video and we'll start filling it in and then we'll talk about it. So let's do the first one together here on the video. We're going to do 1 plus 1 over 10. So basically 1.1, right? And we're going to raise that to the 10th power. So we should get 2.593. And if we continue this with 100, 1,000, 100,000, 1 million, 100 million, and so forth, you start to see that as we continue this on, we'll have more and more digits start to be the same. This number that we have right here of 2.718, and then it'll continue on, is what we call E. So what they're going to do is that they don't stop with just a million, 10 million, 100 million, a trillion. They let n go to infinity. Goes to the end. Remember that end behavior stuff. Goes to the end. Where's it going at the end of the graph? It ends up going to something we call E. And it's approximately, if you want to do approximately, 2.718 da 28. And it does continue on forever. So E, though, is just like any other variable or number. And so since E it's an irrational number, so it never ends, never terminates, never repeats, all those things, you can treat E the same way as you would treat X. Now we can use our exponent rules. What's e to the 4th times e to the 5th?
E to the 9th.
E to the 9th. Whoops. So all of the ones that were there before, so now you got 2e squared to the 3rd power. What would that equal? You would end up with 2 to the 3rd, e to the 6th, or 8e to the 6th.
Yeah.
Okay? So all of the exponent rules still apply here. We also should be able to take our calculator out and can you evaluate e to the 4th power? Yes, this is e times e times e times e if you want to go that way. Or you can just use it on your calculator. Now on a lot of calculators, e to the x is underneath your natural log button, your ln button. So, if you take that, put a 4th power in, you should get something like 54.598. You can go to 2 decimals, 3 decimals, I'm fine with that. Just know how to put it on your calculator.
What the heck?
Now we need to talk about what happens if it becomes this. Yep. A times e to the x minus h plus k. We're going to have to graph this. These are exponential graphs. E is 2.718. It never changes, right? So, we could have an exponential growth graph. If e is by itself, if e just stays e, then yes, we are going to have an exponential growth graph. Unfortunately, sometimes they play with your mind and they change this thing up here. So you might see, this would be exponential growth. 2 times e to the x minus 4 plus 1. It's a vertical stretch of 2. It's moved, translated 4 to the right, and translated 1 up. This is growth. This one, on the other hand, is decay. Why is this one decay and the other one is growth? Yeah, it's a negative in front. That negative in front of the x is going to change things. Now, how do I deal with that negative? We can change it. We can change it so it looks like a positive exponent. And how we do this is we factor it. Factor something out of that denominator or that exponent. What's common in both of those?
Plus 1.
Not plus 1. And up here, what's common is in the exponent. Just here.
What do you mean what's common?
There's a number that's common in both that we don't want there, like negative. So if I put the negative on the outside, then the stuff inside changes signs, right? That's x plus 3. And I think you guys would agree that I like x plus 3 because now you know that is 3 going to the left, still going 1 up, still got a vertical stretch of 2. But here's the thing, I can change this still because this has to be a decay. When do we ever multiply exponents? You multiply exponents when it's a power of a power of power. So, that means this actually is e to the negative 1 to the x plus 3 power. You guys agree with that? Because now it's a power of a power. I don't like negative exponents. Negative exponents do what to my variables? Or to my numbers?
Make them negative.
Not make them negative, but bring them to the top, to the bottom. So that means that this equation now becomes y equals 2 times 1 over e to the x plus 3 plus 1. E is fixed. E is 2.718. If it's on the bottom, it's 1 divided by 2.718. What would that make that number? Not 2.718, it's because it's 1 divided by it. It turns it into a fraction. A fraction that's less than 1. Is 1 bigger or less than 2.718?
Less.
It's less. So 1 divided by a bigger number makes it smaller. So therefore, that's why it changes to 1 over e, which makes it a decay. So there is a section in your homework that's just going to say, hey, is this a growth graph or a decay graph?
So how are we going to tell?
So let's take a look at some examples, some more examples of this. Okay, so this is kind of an example of 4 different types of graphs that it's going to ask you, growth or decay. So looking at the first one, y equals 1/5 e to the 3x. Growth or decay?
Growth.
Growth, why?
This is 3x.
It's 3x. 3x is
Greater than 1.
positive. Look at the exponent. The exponent is positive, so that is a growth. Second one, across the top,
Positive.
it's positive, so this is growth. And the bottom 2 are
Negative.
decay. Because if I was to fix those bottom ones, the bottom ones would be 2 to the e to the negative 2 to the x. Again, negative exponent means the e has to go to the bottom. And so you get 1 over e squared, which is going to be a fairly small number, to the x. So your base is now 1 over e squared, and if your base is less than 1, but bigger than 0, it's decay. And you can do the same thing with the last example.